Limits are the value that is approached by a function. They are used in derivatives and continuity problems. The written notation is limit f(x) of x approaching a value equals the limit of that function. In this project, we will be finding limits numerically. Problem number 3 is limit of x plus 7 over 2x plus 3 if x is approaching negative 1.
Hi, today we're going to find limits numerically. First, we have the limit of x plus 7 over 2x plus 3 as x approaches negative 1. So first, we need to make a table of x and y, and in the middle we need to put the negative 1. Then we need to check which one is the closest number to negative 1. So from the left is negative 1.001 and negative 1.01. And from the right is negative 0.999 and negative 0.99. Then once we have these numbers, we need to plug that in here. So as we can see in the calculator, we have for the first one 6.1. So we need to write it down. Then we plug the second one. Then we plug the second one, which is 6.01. We write it down. Then we need to plug the 999, which gives us 5.98. And the last number 5.8. Okay, so once we have all the numbers, we need to see which number is approaching. So like from the left is approaching 6, and from the right it is also approaching 6. So we can see that our answer is number 6. And there you go, that's it. Alright, and here we're in Desmos, where we graph the x plus 7 over 2x plus 3. And as we can see, if we zoom in, we see that at negative 1, we are approaching the number 6. So that means we are right with our answer.
The limit of x plus 7 over 2x plus 3 if x is approaching negative 1 is 6. Differentiation is finding the slope of the graph y equals f of x. There are several rules for this, but the most basic one is the power rule, which brings the power of x in front of x and then reduces the power by 1. Powers can be positive, negative, or fractions. An example of this is if f of x equals x to the power of 5, then f of x would equal 5x to the power of 4. Problem 53 is f of x equals 3x to the power of 2 plus 4x minus 1.
So for the differentiation problem, we have find the derivative of the following functions by definition. For number 54, we have fx equals 2x cubed minus x squared plus 5x plus 7. First, we need to use the derivative formula. Fx prime equals limit h approaching 0, fx plus h minus fx divided by h. So first, we need to plug the x plus h in the example. X plus h in the x of the example cubed minus x plus h squared plus 5 multiplying x plus h plus 7 minus, this minus is really important. We can see it in the formula, and then minus fx, the function. All of this divided by h. Now we need to expand the cubes and the squares. fx prime equals limit of h approaching 0. All of this divided by h. Now we need to multiply again. Of limit of h approaching 0, 2x cubed plus 6x squared h plus 6h squared plus 2h cubed minus x squared minus 2xh minus 2u plus 5x plus 5h plus 7 minus 2x plus x squared minus 5x minus 7. Again, all of this divided by h. Now we need to cancel. So now it's time to cancel. Here we can cancel negative x squared plus x squared, 5x minus 5x, 7 and negative 7, 2x cubed and 2x cubed. And that's all. So now we have left these numbers and the h. So now we write the numbers that are left. So now we need to factor by getting out the h. So we use the h here and then we multiply all these so we can cancel this h with the division. So now we can cancel the h that is dividing. And we write again the function. So in here, we need to plug the 0 in the h to get our final answer. So here we will have 6x squared plus 6x times 0 plus 2. Plus 5. So for our final answer, we will have fx prime equals 6x squared. This will cancel due to the 0. 0 times something will be 0. And here also. And then we have left negative 2x. And this will also cancel. Plus 5. So we now have our final answer for the derivative problem.